In this lesson, we'll learn about creating and using tables. Lua is especially optimized to use tables. In other languages, these are called arrays, or maybe objects. If you're used to JavaScript, those would be arrays with associative keys. Lua is especially designed to use tables very quickly, whether they're numerically indexed or associatively indexed. So let's create a table. We'll create a local table called T, and we'll use the opening and closing curly brackets to define that table. Within those brackets, we can start to define values. So the first index will be equal to the string foo, and the second equal to the string bar. If we want to access those values, we can choose print t with square brackets, and then the number for the index. Now in Lua, tables are indexed starting at 1, not 0. So 1 will give us foo, 2 will give us bar, and if we try to access an index that isn't there, we'll get nil. So printing this will give us foo. There we go. Lua has a really nice method for getting the length of a table, and it is not this. Okay, don't do t.length. It won't work. Instead, we'll do print, the hash sign, and then the table name, which is t. This will give us 2 because there are 2 indexes. And there we go. If you want to get the name of the table in memory, it would be toString, which is a method to convert the table name to string, and then the name of the table. And then to print the terminal, print toString. And there it is. This is table, and then there's a big value next to that. That isn't really useful most of the times, but there is a particular technique I do show later in the course where you can use that as the index of a table, which is sort of a strange concept. So far, this is a table with numeric indexes. We can also use tables with associative indexes. So let's create a table called hash. And within this table, we'll create a key called foo, and we'll set it equal to a value called foo. Comma, and it's important that it's a comma. The next key, bar, equals bar. Another way to do this is to create a local table called hash and set it equal to just the opening and closing curly braces. Then, to create an associative key, we'll use .syntax. Hash.foo equals foo. Hash.bar equals bar. Both of these methods will produce the exact same results. If we want to get these values, then we can do it one of two ways. We'll want to print them, and we can use square brackets, so hash square brackets, and then the value as a string, so foo. That will print foo. Or we could use .syntax to access the value. Print hash.foo. And both of these methods are the same for retrieving the value at the foo key in the hash table. You can even nest tables if you want to, so we'll wipe out the old table t simply by redeclaring it. Local t equals, and then start and close some curly braces. And within this table, the first index will be a table itself. And within this table, we'll create 2 values, foo and bar. Then a comma outside of the table, so this is the second index. And this will be 3 values, hello, there, and everyone. Comma, and we can also mix and match numeric indexes and associative indexes in the same table. So we'll create an associative key and set it equal to a table. So here we have an associative key that is a table itself, and I know now it's getting a bit confusing. So within this table, we'll have the key bar equals nested barness, comma, and then vintage equals the number 75. Okay, so we've got a big table called T. It's got 3 entries. 2 of them are numeric, and that's the first 2 entries on line 21 and 22. And the third is associative, and that's at 23 through 26. All 3 are tables themselves, and the entry at 23 is associative. Now, if we want to access these, we'll do the following. print. Let's say we want to access bar in the first index, which is right here. Well, this is the first index of T. And then within that first index, it's the second index. So the first index, then that gets us this table, and this is the second index of that table. So this prints bar. If we want to concatenate some of these strings in the second index, we can do the following. We'll print, then we want the second index, and let's say we want to get the word there. We'll concatenate that with a comma, and then the word everyone. And there we go, there, everyone. Finally, we can still access the associative key through dot syntax. And we can use dot syntax again to get the associative key of foo. So this will print 75. In case you're wondering, you can't do something like this. Print t.1. This will give you an error. Take a look at it in the simulator. And here it says parentheses expected near .1. Well, actually, it should tell you, look, you cannot access numeric indexes in that way. We'll go ahead and delete it. One final note about hashtags to get the length of a table. You can only get the length of numerically indexed tables. So for instance, let's say we wanted to get the length of the foo table within T. We can't do this. Print hashtag t.foo. This will actually return 0. And that's because foo is associatively indexed with bar and vintage. The way in which you would get the length of an associative table is you'd have to iterate through it and then count the total number of entries. We're not going to go through that in this particular lesson. Finally, when you're done with your table, it's good to nil it out. And this will totally wipe out your table, and it will mark it for garbage collection. This ends our lesson on creating and using tables.